Hi, in this video we are going to talk about multimeters and breadboard. So two important things that you may need. Again, like this is not requirement. Like say we don't have to have a multimeter to construct a circuit, but it will be nice to see what is actually happening. Because say a battery that you have will produce 9 volts because it is mentioned on the battery, but like how many volts is it actually producing? So if you have a meter, you can test them out. Likewise, the current flowing, you can you know all the formulas, and we also know how to calculate the resistance of a resistor with the color band present in the resistors. All those things are possible, and if you know the resistance and voltage, you'll be able to calculate the current, but actually how much current is like flowing through that. So there are like a lot of assumptions we make, but to be accurate, to kind of like find them accurately, you might need one of these meters. Like we used to have voltmeters, current meters, that's called ammeter, and ohm meter, like which will calculate resistance. But these days we don't use any of those. We have something like that combines everything, and sometimes we have some with more added features as well. Those are called multimeters. So multimeters are test tools that measures two or more electrical parameters, but most commonly they would be able to do voltage, current, and resistance. So a multimeter, you can get one of these meters at Canadian Tire, like for like maybe $20 or something like that. Early on, or like maybe $30, I believe, right now. Early on, like we used to get even for like a lesser price, but like it was like very cheap, cheaply built. Not great though. But again, this is like very useful. So if you wanted to check the voltage in a battery or something like that, these ones will be really come in handy. If you are really doing a lot of work, I would recommend or like electrical work, I would really recommend fluke meters. Like say these ones are around like $100 to $200, and these are like awesome, really. It's very well built, and the most important difference between these meters are that again, these ones will come with probes as well. So here, like you will have to pick and choose the range actually. So when you set a range, and let's say you wanted to measure like ohms. So here we have ohms, and here like we have DC voltage, and here we have AC voltage, and alternating current and direct current. And so if you wanted to just say measure like resistance of a resistor, you thought it was like somewhere in the 2000 ohms range, so you applied, but it seems like that was in that was like say 5,000 ohms, maybe 5 kilo ohms, something like that. So then like what will happen is like when you set the range here, like it maxes out, like it will say it's infinite. Then like you will have to move the dial to 20 kilo ohms so that like it will read 5 kilo ohms. So you will have to set the right range to kind of check the resistance, voltage, or current, like whatever it might be. But in this case, these are all like auto ranging, so which means like you don't really have to set it in a particular dial. So if you connect it, if you move the rotary dial here to ohms, whatever resistance it might be, it will kind of like spit out the result. So that is kind of like the advantage of these. And the another thing is like it can do like say frequency, and it can do continuity. Continuity means like say if you wanted to see like you have like a PCB, you are not sure if there was like a break there or like there was like a short circuit or something like that. To just check those things out, like you can like use these. Sometimes a wire might be cut somewhere, like let's say you have a wire and like the wire is broken for some reason, and you did not realize, like you wanted to check the continuity, you wanted to see if that is like working, that wire is like not broken anywhere, so you can use those to check the continuity. So there are like a lot of uses for these multimeters. Again, this is not required for this course, but I still thought I will let you know this, so that like if you are doing some work related to what we are studying right now, this will come in handy. And breadboards. Breadboard, the name comes from, yes, breadboard. Early on, like we used to, or not we, maybe they used to, like say, do prototypes in this board. And that was really inconvenient, actually inconvenient, because like you need to say screw all your components in and then like use a wire like and physically connect everything. So the same circuit can be easily done with a breadboard, like what we call a breadboard right now. So you should have one of these in your kit. So we just have tiny holes where you can insert the components, and then like there are jumper wires like which can be used to wire your circuits. So this is called a breadboard. The way they are connected is this actually. So there are two rows that are all connected together. So these connected, horizontally connected rails are called the power rails. So we use these rails often to connect it with the source. So it has a positive and a negative. So you connect the positive end of the terminal and the negative. So positive end of a battery and the negative end of the battery to here to these rails, and so that like when in the components, like you build your circuits here in this region, and then you can draw power from these power rails. So that is how we do. So all the vertical columns, so these ones are all connected. So if you just open up a breadboard, like say behind, like there'll be a small insulated material, you can just remove those. If you remove those, like this is what you will see. So these are the actual pins. So those are all connected together. So let's say you have an LED, so you will connect one lead, like say an anode in one hole and a cathode in another, but you will not be connecting it on the same vertical side though. So you'll be connecting, maybe I'll go back to this, you'll be connecting them like this actually, so horizontally. So one in one channel and the other one in the other column. Sorry, maybe instead of channel I will use the word column. So one terminal goes in one column, the other terminal goes into the other column. So if you wanted to connect another component in series to that, like then you will be connecting one side of the terminal to that, and then like it goes back to another column. Okay, so these although we say columns, so there is not all columns are connected together. So for example, say these 5 columns or these 5 rows of the first column is independent of these 5 columns in these 5 rows in this column actually. So they are not connected. So this is how they are connected. Okay. So now let's go into a simulation part, like which is really fun. So you don't have to physically do everything to just like test out a circuit. So we can kind of simulate it. So that simulation can be done in what is called a Tinkercad. This is a free software provided by Autodesk. Again, you don't need to install anything. So this is all cloud-based. So you can create a circuit and you can save them there and you can test them there, and once you are happy with the circuit, and then like you can implement that on a breadboard and see it working like say in real world actually. So it's not going to be virtual anymore. So you can do that. The best thing is that they have like basic components, and apart from that they have Arduino Uno. So you can program Uno in there and you can test Arduino as well. So that's why Tinkercad is awesome. And I will finish this video right here. And then I'm going to let you know how to create an account in Tinkercad, and then we will start designing circuits there. So see you there in the next video.